All right, welcome and congratulations on surviving your first quiz, or maybe not surviving your first quiz. I'm realizing I have way too many green shirts, but it is what it is. All right. So we're going to start this video by talking about what is a function. Okay. And we'll get some examples of things that are functions and things that are not functions. So starting off, right? A lot of times we'll write functions as something like this: f of x equals y. All right. Pronounced f of x. And so this is the function name. F, G, H are very common ones. This is our input, our x's. And that's going to be our output, is our y's. Okay. And a lot of times we'll get into this more in the next section next week, but the set of all inputs is the domain. So there's that correspondence between input and domain. And the set of all the outputs is the range. So there's that relationship between the y values and the range, for example. Okay, so one of the most important things when you're looking at what is a function for purposes of our class has to do with the number of outputs. Okay, so a function, only one output per input. Okay, think of it like a machine or something. You put something in the machine, you get something out. All right. And another way to think about it is multiple choice questions, right? You're taking a test or something, a multiple choice question. You can't just bubble in all the answers, right? You only should have one answer for basically everything. And don't box multiple answers on my quizzes or exams either. I will get very upset. Okay, so that's kind of what we've got here. So let's look at some examples, things that are functions, things that are not functions. Let's make this a little bit more concrete. Okay, are these functions? Example 1. Part A. The set containing the ordered pairs AB, AC, and EF. This is one way to look at a relation. A relation is something that may or may not be a function, but kind of is similar. So this is just a set of 3 different ordered pairs. If these were numbers, we could graph the ordered pairs. Okay, we could just go off to the side and say, oh yes, these are the 3 ordered pairs, and decide whether, that's a function. We'll talk about how to look at things graphically at the end of this video. But these are variables. We can't graph these. We don't know what A, B, and C are, or E and F for that matter. I skipped D apparently, but that's okay. So each input should only have one output. So let's look at the inputs. What are our inputs? Our inputs are A again, that makes me nervous already, and E. Our outputs are B, C, remember the outputs are those y values, and F. But the problem is that we have A is our input, A goes to B, and A also goes to C. So we have an input that is going to multiple outputs. That's no good. That's boxing 2 answers on a math quiz. That's filling in 2 bubbles on a multiple choice test. No good. This is not a function. Okay? Because A goes to B, and A goes to C. Each input can only go to one output. All right, let's look at part B, something separate, similar. Looks very similar, actually. AB, BC, and CD. So you might right off the bat say gut feeling, ooh, I see a lot of reusing going on here. A lot of the same letters popping up. But it's okay. Because look at this, what are inputs? A, B, and C. A, that input, only goes to B. B only goes to C, and C only goes to D. Every input only occurs one time. Okay, so this actually is a function. We'll say yes, smiley face. Include that smiley face in your answer. It's a very important part. And that's sarcasm. You don't have to include the smiley face. Okay. Excuse me. That's another example. Part C. What if, instead of relations written like that, what if we have equations? Is this a function? Well, we can kind of look at it, right? Like, and the particularly astute math observer may say, ah, I know what this is. This is an equation of a line. Lines are functions, most of them, not all of them. Or you can just look at some x's, right? If we can make a table if we wanted to. If x is 0, can y be multiple things? Or is y only going to be one thing, right? Function is that if I give you an input, you only give me one output. So if there's multiple things over here, it's not going to be a function. But again, we can look at this. If x is 0, y is 3 times 0 is 0 plus 5. Okay. If x is 0, y is only 5. If x is 2, I don't know, y is going to be 3 times 2 is 6, plus 5 is only 11. No matter what x value I give you, there's only going to be one output. We're going to say yes. We're going to say yes and fit that on the screen. It is a function. And maybe you didn't want to include the smiley face this time. That's okay. I'll forgive you. All right. Let's do another one. Part D. 5x squared plus 3y equals 2. Looks a little bit more complicated. Maybe it's a function, maybe not. Okay. Let's, kind of do a similar thing. Let's say x is positive 1. Well, then what do we get? We get 5 times 1 squared plus 3y equals 2. Okay, let's subtract this is just 5 right here. 5 plus 3y equals 2. Subtract the 5, we get 3y equals negative 3. We get that y is going to equal negative 1. That's the only thing that y can be if x is 1. Okay. Similarly, what if x is negative 1? Well, if x is negative 1, almost nothing changes except that's a negative 1. But when you square it, it still becomes positive 1. So this still becomes positive 5, and the same steps go on, and y is still negative 1. And you might say, aha, I caught you, Jason. This is not a function. But it actually is, right? If I give you x, it only goes to a single y. If I give you a different x, it only goes to a single y. It doesn't matter that these are the same, right? These being the same, my head's blocking it, doesn't matter. So again, every single value is only going to have one answer. This is again going to be a yes, and with a really happy face. All right, that's a little creepy. Yes. Okay. So I'm trying to develop a pattern here with a lot of these functions. Let's do 2 more examples, and then I'm going to give a little summary. Part E. That's not a blank piece of paper. Part E. Okay. What have we got here? Well, I'll tell you. Y squared equals x. Ooh, I forgot to force focus my camera. So if y squared equals x, you can make a table again, and you're gonna see something. Another way of approaching this problem is if you solved for y. Okay, and a lot of people like approaching these problems solving for y. You just have to be a little careful with doing that, what it looks like. Okay, so let's say I'm solving for y here. If I wanted to solve for y, I would have to take the square root of both sides. But remember, when you take the square root of both sides, you get a plus or minus. If I'm looking at my table over here and say, well, what if x is 1? Well, then y is going to equal plus or minus the square root of 1, which is just 1. Uh-oh. That means y is positive 1 and negative 1. I gave you an input, and I also gave you 2 outputs. Okay? This is 2 outputs. That's no good. Okay, so we're going to say not a function. Give it a little sad face. Okay. Or you might even see this more explicitly, right? If you have something like x is equal to plus or minus sorry, you might get something that looks like I'll know y plus 5 is equal to plus or minus the square root of 1 minus x or something like this. Okay? Again, when you see that plus or minus having to do with the x's, that's going to usually mean that it's not going to be a function. Again, this is also going to not be a function because, for example, right, if x is 0, then we get y plus 5 equals plus or minus the square root of 1 minus 0, square root of 1, or just y equals negative 5 plus or minus 1. That's negative 6 and negative 4. So again, multiple outputs. It's not a function. So what's the summary here? What's the summary before we move on to the last part of this video? Video is already getting a little longer than I usually like them to be. What's the summary? The summary, right, is if you have y squared or a plus or minus in front of an x, probably not a function. I won't say probably, but I'm going to say not a function. And the reason I was going to say probably is this is not like a theorem or anything, but this is a good rule of thumb for you to use as you're approaching these problems. Okay. Last part. Well, last two-ish parts. Ish, sort of. What about if I give you a graph? Is this a function? Well, you have to check, okay, does every input only give one output? Does every x only give one y? So for example, if I gave you this x coordinate, say that x coordinate's 2, I don't know, what y coordinate corresponds to it? Only that, right? Only this y coordinate corresponds. So an input only has that output. This actually is a function. Whereas what if I gave you a sideways parabola and gave you that same input? Well, now there's a problem. There are two y values that correspond to that input. It's no good. This one's no. All right, and if you are familiar with something called the vertical line test, this is a good time to use it. So in general, right? Vertical line test. In general, if there is a vertical line that crosses the graph more than once, it is not a function. So on this first graph, right, I can, use my pen, do a vertical line everywhere here. Notice the pen is only crossing the function once, any given time. Whereas on this function, pretty much everywhere, right, this pen is crossing the graph twice, almost everywhere. And because it's crossing multiple times, it's not going to be a function. So use a vertical line test to identify whether graphs are functions. All right? And you should be all set up to do the first chunk of problems. I'm not going to write them down in the videos anymore, but they should be right above the video. All right? Good luck.